Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the minimum time to make rope colorful problem. Alice has n balloons arranged on a rope. You are given a 0 index string colors, where colors I is the color of the ith balloon. Alice wants the rope to be colorful. She does not want 2 consecutive balloons to be of the same color, so she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You are given a 0 indexed integer array needed time, where needed time I is the time in seconds that Bob needs to remove the ith balloon from the rope. Okay, maybe these are lead balloons and take a while to pop. I'm not quite sure why, whatever. Anyway, return the minimum time Bob needs to make the rope colorful. So this one here, these 2 balloons are the same color. That's not colorful enough for Alice, apparently. So one of them needs to go. And we chose this balloon. So here are the needed times. 0, 1, 2, 0, 1, 2. This one has cost 3 to pop. This one has cost 4 to pop. So we're going to pop the one that only costs 3 to pop. This is already colorful, so we don't need to do anything. And this one here, these 2 are the same color, and these 2 are the same color. So one of them from each needs to go. And it's the ones on the end that are the cheapest, so they're the ones that go. So when I see this, I'm immediately thinking it's a variation of run-length encoding, because we're interested in the things that are next to each other. So here, this is 1A, 1B, 2 A's, 1C. It's that 2 A's that we're interested in. We basically want to make a run-length encoding where every run length is 1. So from each encoding that has greater than 1 run length, we just want to find the 2 indices that are cheapest. If it's a run length of n, we want to find the n minus 1 elements that are cheapest in that run length. So if we do the RLE, let's do runs is the empty list. Run is also an empty list. For color in colors. Actually, let's do this slightly differently. I'm going to do none. No, hang on. So if last color is none, last color is equal to color run.append needed time. Whoops, I need indices for this because I'm going to be doing these 2 arrays in parallel. I'll get back to why I'm doing that in a moment. In fact, no, I'll talk about it now. So normally when you're doing a run length encoding like A, B, A, C, this will turn into 1A, 1B, 2 A's, 1 C. But here what I actually want to do is turn this into a 1, 2, 3, 4, 5. So I'm doing the run length encoding algorithm, but I'm not using the elements of the string. I'm using the elements of time and not collapsing them so much as just aggregating them. If color does not equal last color, runs.append run is equal to the empty list. In fact, no, run is equal to needed time I as a singleton. If run does not equal the if run runs dot append run. So what this should do Actually, what I'll do here is I'm going to print runs. So let's just see where we're at. What this should do is give me the 1 singleton, the 2 singleton. Whoops, it should also give me the 3, 4 singleton. Run.append needed time. So I'd forgotten a case here. So I handled the case where the colors are different, but this is the same as the previous one. So I needed to put the 3 and the 4 together. Although, why did the 5? Zero, 1, this, so this, the last color is none, so this one is easy. Let's see, what am I doing wrong here? 1 is handled, then we go 2. Last color does, if the color, okay, so last color gets set to blue. Oh, yeah. Oops, no, that one's fine. It's this one here. The last color is color. I didn't update the actual color I was looking at when it changed. Silly, silly. There we go. That's what I'm looking for. 1, 2, 3, 4, 5. So now I have the runs. This run is of the right length. This run is of the right length. This run is too long. So we want to remove the... well, no. What I want to do is I want to add them all up and subtract the largest value. That's probably the easiest way to think about it. And then that one's of the right length. So now what we want to do is let's just create a total for run in runs. If len run is greater than 1, dot plus equals sum run minus max run. Return tot. So this one here, using this is fine, this is fine, this is too long, so we add them up, 3 and 4, and then we take away the max, which is the 4, so it's 3 plus 4 minus 4, so it's just 3, and then that one is done. Let's use all the example test cases. So the runs there were correct, the runs there were correct, the runs there were correct. I think that's fine. This sum minus max. Hard to know whether that's inefficient or not, because both of these are order n. It'll be fine. It'll be fine. We don't need this print statement anymore, though. So the reason I'm humming and hawing about this is it's 2 passes through. And in theory, I could do a for loop here, which is sum without max, basically. Create a little function that does just that, which is order n time. But I would be willing to bet sum and max are not actually implemented in Python. They're probably implemented in C. So it will be much, much faster than that for loop that I write. It's wild speculation. We can try it at the end. Assuming I get it right. There might be an edge case I've missed here. Nope, we're fine. We were really fast, like really, really fast. That's surprising. I'll take it. Excellent. Okay, do we want to do this little test? Let's do this little test. Def sum without max nums max equals none. Let's call it m is none. t is 0 for I in nums. If I is greater than m, m equals I, t plus equals I, return t minus m. Let's just quickly, oops, I didn't actually update this. It's sum without max run. Oh, if m is none or I is greater than m. To handle that case, yes, there we go. So let's submit it and see if it's any faster. Significantly faster anyway. If it's within spitting distance, it doesn't really matter. It's much slower, much slower. So this is where I think sum run minus max run. If we go back to this case, do we go back to being much faster again? No. Okay, that's surprising. It seems we're all over the place in terms of runtime. I'm going to put that down to the Leetcode servers. There's no way. That was identical code and it doubled in runtime. So, yeah, your guess is as good as mine as to why that changed so dramatically. Pass. Anyway, that will do us for today, I think. Not a bad one, a fun one, an interesting problem, sort of a hidden run length encoding problem that you have to do on a parallel array, which is quite cool. Anyway, that will do it for today. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.